Hello students, in last video of solid state, we have started a very important concept which is crystal defects, and till now we have completed two types under stoichiometric point defects, which is vacancy defect and the self-interstitial defect. So the third defect under stoichiometric point defect, which is Schottky defect. Now, as you can see, I have written a very important point in case of Schottky defect, which is ionic compound. Now, what does this means? So basically, Schottky defect is seen only in ionic compounds. Now, what is basically ionic compound or ionic solid? Basically, the particles are positively charged and negatively charged. That is, they are called as cations and anions. Means the particles in case of ionic compound are always cations and anions, and in only this kind of compound the Schottky defect is seen. Now, what is actually a Schottky defect? So basically, equal number of cations and anions are missing. Equal number of cations and anions. Cations means positively charged and anions means negatively charged. So if equal number of cations and anions are missing from their regular sites in the crystal, creating vacancies, it is called as Schottky defect. Now, for example, if I erase this one negative charged particle, that is negative ion, and one positive ion, now you can see that there is vacancy here as well as vacancy here. So there has been created two vacancies per ion pair. So two vacancies per ion pair, per pair of ions. So one being positively charged and other being negatively charged. So we can say equal number of ions, that is equal number of cations and equal number of anions are missing from regular sites, then that defect is called as Schottky defect. So suppose one positive charge is missing, one negative charge will be missing. Two positive, two negative, three positive, three negative. So another important point, which is equal number of cations and anions are missing from their regular sites. So this is about Schottky defect. Now, what happens to mass, volume, and density? As we always discuss about mass, volume, and density in case of defects. So basically, one positive and one negative ion is missing. So mass will definitely decrease, volume will remain same. And what about density? If mass decreases, density will also decrease. So these are again very important points regarding this defect. Now we will move further, which is Frankel defect. The fourth defect for under stoichiometry, which is Frankel defect. Okay. Now we will see with the help of diagram. So in case of Frankel defect, as you can see here, the diagram I have shown. So basically, again, this is happen in ionic compound or in ionic solid, where the particles are nothing but cations and anions. As you can see that there is creation of vacancy. So basically in this defect, vacancy is created. How? That we will see further. So again, the vacancy is created due to some particles or due to some ions which are positively charged particles, and they have misplaced their original sites and they are placed interstitially, that is in the voids. So basically this type of defect is nothing but vacancy plus self-interstitial defect, because generally the positive charge particles, that is cations, misplaces from their original sites, creating a vacancy, and they placed interstitially, that is between the ions or between the voids. And why generally cations? Because cations and anions, if we compare both, the size of cations and anions, generally size of anions are much more larger than the size of cations. So it is easier for cations to move from their original position and place interstitially. So this is very important point. So basically we will revise ionic compound or ionic solid. So this defect, which is Frankel defect, happens only in ionic compound. Again, it creates vacancy. Why? Due to some charged particle, that is generally cations, misplaces from their original site, so vacancy created, and they place interstitially, that is in the voids, that is the spaces in between the particles. So they are placed interstitially, and also this defect is nothing but vacancy as well as self-interstitial. So this is an example of vacancy defect as well as self-interstitial. There is both vacancy as well as self-interstitial in a single defect. Okay. So this was about Frankel defect. Now we have completed part of stoichiometric point defect. In next video, we will consider impurity defects and non-stoichiometric defects. Thank you.